got Marcin Kacperczyk presenting first. So he'll present for 25 minutes, and that will be followed by 10 minutes of questions by the audience. And then Xander will be presenting. And again, same format, 25 minutes, and then 10 minutes for discussion afterwards. Let's limit the question during the presentation to only clarifying questions. So let's sort of the bigger, more fundamental questions is better to leave for after the presentation. Then I'd like people to put on their cameras, if possible, just to have a more sort of a personal touch to the seminar series. And I think that's it from my end. So Marcin, please go ahead. You have 25 minutes.
Okay. Thank you very much, Kim, for your kind invitation, and also to Laurent and Raman as well for co-organizing this really wonderful series. So I'm going to talk about the project that is joined with Patrick Bolton and Moritz Wiedemann. Both of them are at Imperial. So just as an advertisement, Moritz is a bright PhD student who is on the job market this year. He has very strong endorsement from both me and Patrick. So I strongly encourage everyone to look at his application if you are looking for really good scholars to work in your group. Okay, so the topic of the paper today is related to the problem that many of us have been thinking about, even passively, by just observing what's happening in physical atmosphere, which is climate change. And the perspective that we want to offer on this particular question is related to the role of technology in solving this particular problem. So essentially, the starting point for this presentation is a little bit of a prior that a lot of people have, which is essentially the idea that if we want to solve the climate problem, this is not going to happen necessarily through basically policy kind of decision, but this is going to happen more through some kind of technological revolution. And this point has been highlighted by many people. Here you have a couple of quotes from people we typically see in terms of kind of private world as the gurus, so Larry Fink, Bill Gates, etc. They talk very strongly about green innovation essentially being called a silver bullet. And the question that we try to answer in this question is essentially a question on this bullet point, which is it really a silver bullet? To what extent can we argue that innovation in the green space is going to solve the decarbonization problem? So we are going to inform this question through some kind of empirical investigation to try to see to what extent we can argue that innovation in some kind of green technologies leads to decarbonization progress. And to kind of inform this empirical investigation, we want to lay out some conceptual framework. So in a traditional way, people think about innovation. This is expressed by people like Philippe Aghion and others. The story is that essentially innovation fosters investment in green technologies, and that as a result leads to implementation and a kind of a good outcome in terms of reduction of emissions. So in this model, brown firms essentially change their profile from carbon intensive to renewable production, or alternatively, they can also improve efficiency of their fossil fuel production. These papers typically kind of argue not so much for the channel of how to foster innovation, that innovation works, but more so what it is that we should do actually to foster the innovation. So their focus is more like under the assumption that innovation works. So what we want to argue in this paper is that this view is just one of the possible kind of mechanisms, but it's not the only one that you can put on this particular question. So there are at least a couple of other ways in which you can think about the role of innovation in solving this particular decarbonization problem. So one way that you can kind of argue is dating back to the work of Jevons and his famous paper on coal, where he essentially argued that if you innovate in a particular space, what this may actually create is an additional demand for a particular product. So even though you actually are going to improve on the efficiency on the per quantity kind of use of the product, the aggregate actually contribution of the product to something like an externality could be potentially negative. So he called it a the carbon question or the carbon problem. following that kind of framework of Jevons, we are going to ask kind of a similar question in the context of greenhouse gas emissions. To what extent actually the innovation in efficiency of producing energy is potentially going to create this kind of Jevons paradox, or sometimes people call it a rebound effect. And alternatively, you can also think about other kind of ways in which this can actually inform the decarbonization. So you can think of contributions of Arrow. So in the famous papers by Arrow, he argues that companies may have actually disincentives to change if they actually have a high market share in a particular technology, or if they actually acquire some kind of expertise in what they are doing. So the two effects I'm talking about is a famous replacement effect and also the so-called learning by doing economics. So both of them kind of argue that there may be incentives by which companies may actually want to stick to what is the current status quo in terms of their technologies. And then related to this two, what we want to also argue is that even though you may actually solve the problem of decarbonization in terms of reducing emissions at the source, what may happen is these emissions may actually get displaced somewhere else within the production network. So here is the example that we like to think about is an example of, for example, Tesla. So we all consider Tesla to be a green company, and it's admittedly true that on a direct emissions, that Tesla does not really contribute much to the greenhouse gas production. But we all know that in order to charge Tesla, you need to use energy, which essentially means someone else may actually burn the fossil fuels to produce that. And you also need to produce Teslas, which essentially means there could be some kind of emission production in the production network of Tesla. So even though you solve the problem in one place, as we are saying, there could be a displacement of emissions into another place in the economy. So in order to answer these questions and kind of evaluate the relative merits of this different hypotheses, we are going to bring in data on the large scale of innovation from a global context. So this is going to be the data on innovation and related emissions from over 80 countries. And we are going to use the relatively recent time period for this investigation, which is 2005 to 2020. And there are going to be a few questions that kind of relate together to this question of, does it really matter? And we're going to start by showing you something on this question of replacement effect and learning by doing, which essentially asks to what extent do we observe that technology progress leads to some kind of change of the profile in the way companies actually produce their emissions. So we will try to see whether there is actually a path dependency in the way in which companies are innovating, or maybe companies in the process of innovating are actually also changing their profile from being brown to being green kind of companies. And then we are going to assess the following questions, which is essentially the question to what extent there is an evidence of Jevons paradox, meaning that even though efficiency could be improved in terms of per unit production of energy, the aggregate consumption of energy can still be higher because people are going to demand for more of that product. And finally, is there any evidence of displacement of this particular emissions to other companies within the production network? So the data is fairly standard in the context of innovation, but maybe for those of you who may not be fully familiar, we are gonna rely on the data from Orbis. So Orbis is a really wonderful data that summarizes information about all the patenting activity globally. And we are gonna retrieve information on patenting activity of both public and private companies. We are gonna append this information with lots of different firm level characteristics to control for as many confounding effects as possible. And then we are going to merge this information with information on emissions at individual level of firms. So here we are going to distinguish between direct emissions scope 1 and indirect emissions, which is related to consumption of energy scope 2, and also production in the production network, both upstream and downstream, which is what we define to be scope 3. So importantly, in our discovery, we are going to focus on publicly listed companies because this is the data for which we are going to observe emissions. But the innovation that we are going to look at is actually innovation that is going to be produced both by public and private companies. So the data is very rich. It offers information on a lot of companies. And just kind of to give you some highlights, we are going to have more than 11,000 companies with full information on financial patent and emission data. Some of these companies are going to be active in green patenting activity. Some of them is going to be active in brown patenting activity. In a moment, I'm going to tell you how we define that. So green patenting activity or green technology is going to be essentially the technology that substitutes carbon dioxide with something that is dioxide free. Brown efficiency instead is going to be the technology which makes the consumption or the use of fossil fuels more efficient. So essentially in the first world, you are expecting that companies are not going to contribute to emission production. In the second world, you are just expecting that the efficiency of using the fossil fuels is going to be essentially better. So we are going to follow standard classification to define what makes a green versus a brown efficiency patent. So the standard source for this kind of classification is OECD. We are going to append this classification with additional classifiers. So in the paper, we try to argue that actually additional information potentially makes the data a little bit less noisy. But importantly, all the results that I'm going to show you do not depend strictly on how we have classified this, whether we use the OECD only or whether we use a little bit more comprehensive set of classifiers. So important for the results I'm going to show you today, I'm going to focus on a specific way in which companies are going to register patents. And we are going to focus on patents which are actually registered with European Patent Office. And the main reason why we are going to do it is that in the literature on innovation, it is actually quite understood that companies that actually register with European Patent Office are actually considered to have patents which are more important. So in some sense, if your null hypothesis is that there could be no effect of patenting activity, at least we are providing a slightly stronger, lower bound in terms of this being important or not. And our main measures of innovation are going to be very standard. So we are going to look at innovation intensity in terms of the ratios of how much companies produce in terms of green and brown patents relative to their total innovation activity. And as a robustness, we also are looking at importance of patents, which essentially is measured in terms of the citations that patents receive from being used. So in terms of empirical specification, there are going to be kind of two lines of investigation here. The first one will be along the lines of the persistence or the basically the path dependency kind of mechanism of innovation. So we will try to understand what really predicts the innovation activity. And here the main control is going to be, the main controls are going to be related to anything that is kind of informative about the technology and the firm type. Among others, the level of emissions is going to be one of the key variables. In the second model, we are going to look more directly at the effect of this patenting activity on the carbon footprint. So here we will try to predict the impact of innovation on the future emissions. And this is going to be related to 1, 3, and 5 years future emissions along the corporate kind of path. So let me show you a couple of results. So the first set of results are essentially results which are supposed to tell us something about the path dependency of innovation. So the left-hand side variables in this table are either the green ratio or the brown ratio. So these are the kind of intensities of innovation in the green space and in the brown space. And what we are observing in the highlighted rows are essentially the three kind of sets of predictors that we think are relevant for the path dependency. So in the first row, we look at the level of direct emissions, scope 1 emissions. And what we observe is something quite interesting. Column 2 and 5 are the ones that probably are the most important for our investigation, which is within a given industry, companies which have less emissions are actually more likely to innovate in the green space. Companies that have higher level of emissions are more likely to innovate in the brown space. So this is consistent with the path dependency story in a sense that level of emissions kind of links back to where actually the carbon footprint in terms of innovation would be located. Moreover, what we find is that the stock of innovation is also very highly predictive of your future innovation. And that's represented in this green box, where you find that the stock of green patents strongly predicts the future activity in the green innovation. and the stock of brown patents predicts the future activity in brown innovation. And finally, kind of consistent with the story of the technological legacy, we find that the older companies are more likely to innovate in the brown patenting activity, whereas the younger companies are more likely to switch to the green activity. So in some sense, the idea of switching the type is not so much of the companies switching their basically profile. It's more that you are going to observe more entry into these markets if we hope to have more green innovation as a result. So it turns out that this result also works with the intensive margin. So this is focusing purely on companies that innovate. The previous table also included companies that do not innovate. The same type of results go through. So what's also interesting about the result is that this idea of path dependency is going deeper into the production network. So it's not just the story that companies with direct emissions are more likely to produce more brown efficiency patents. It's also the story that companies that actually have higher emissions in the production network, for example, scope 3 emissions, are more likely to innovate in the brown efficiency. So in other words, you can argue that the path dependency story is a deeper story than just the story of a kind of firm level nexus. So that's kind of the first part that seems to suggest that companies are sticking to what they are actually doing in terms of their innovation and kind of profile of operation that they have. Of course, the key kind of questions to ask is, does this matter for what actually happens exposed with their emission levels? And this is where we want to bring in this additional investigation, where we will look at this innovation activity and try to see to what extent this affects firm level emission outcomes. So the first investigation that we are looking at here is very simple, where we are linking the innovation of each individual company to its own future emissions. So this is essentially represented in columns 1 through 9. I apologize, there are so many numbers here. I am sure that it's not so easy to look at it. But just to summarize what you see in this data is we find some evidence that innovation actually improves efficiency of emission production. So this is kind of especially seen in terms of the brown efficiency patents. But what we find also as a result is that the combined or aggregate amount of emissions is actually increasing for companies which actually innovate more, especially in the brown space. So this is highlighted in this red ellipses that you see to the left of the table. And the question is why this is happening. This is partly answered by the right side of this table that shows you that companies that actually innovate more in the brown space are also companies for which actually the sales increase. So in some sense, this is like one way in which you can see the presence of the Jevons paradox. It's not extremely strong, but think of it that the story is kind of set up against finding it, because the traditional way of thinking about this problem is that we should observe the reduction in emissions rather than an increase in emissions. So that tells you that this Jevons paradox in some sense overcomes this alternative channel that could be actually operating at the same time in the data. So then we look at other actually margins of understanding this problem. And of course, there are many ways in which you can think about this problem. You may say that these patents are too early, that maybe it takes time to actually innovate. Maybe these patents are actually too incremental. Maybe they are not so important. Or maybe what's happening is that we are looking at companies which are very diversified, and in a sense, R&D activity is only a small part of their operations. So we kind of take all of these questions on board in the paper, but they are kind of less of our focus today. What we instead want to talk about more is an alternative story, which is a story about the general equilibrium effects of innovation. So essentially what you may argue is that innovation that is created in one company is not necessarily destined for that company's emission itself, but it's actually supposed to benefit the whole ecosystem of companies which are related to that very company. So you may think about Tesla producing batteries that are actually going to be used by many other companies. And in that way, we may benefit from this particular innovation. So in order to answer this question, we are going to look at two specific margins. In the first margin, we are going to look at what we call the spillover effects. So we are going to look at the effect of innovation in the industry on all the companies in that industry. So we are going to look at the distinction between companies that are involved in patenting activity versus the companies that are not involved in the patenting activity. So they are just the pure beneficiaries of innovation of other companies. And essentially what we are going to find is that this effect is actually not there as well. If you look within the same industry of companies that are innovating, we find, if anything, that innovation, especially in the Brown efficiency patents, leads to actually higher emissions, especially in the scope 2 and scope 3. And that may not be actually that surprising, because if you look at some of the anecdotal evidence, we do see, for example, evidence that companies that, for example, power the electric vehicles oftentimes rely on electricity that is actually quite fossil fuel intensive. So as an example, 91% of electricity in West Virginia is coming from coal. Similarly, 75% in Missouri, 74% in Wyoming, etc. So in some sense, this is consistent with this story of displacement, where even though we are kind of reducing the emissions at source, we are actually transferring these emissions into some other parts of the ecosystem of the company. We also find that this effect does not depend too much on whether the companies innovate or not. So in some sense, it's not that there is some kind of a subset of companies that benefit. On aggregate, either of the two groups of companies actually do not observe much of the reduction in emissions. When we look at Brown kind of efficiency patents, we also don't find very strong effects, even though in terms of efficiency, there are some actually indirect reductions in emissions. And then the second kind of channel we are looking at is the channel where you may think it is not just about the industry itself that you should be looking at, but maybe it is about kind of related sectors that potentially benefit from that. So in order to answer that question, we are going to look at adoption of patenting activity outside of the very industry of a company. So the way how we have defined this particular test is essentially we are going to look at a very coarse industry. And without a very coarse industry classification, we are going to select out subsets of more granular industries. And the question is going to be, within this granular kind of subsets, is the innovation in one subset affecting the emission activity of all the remaining subset within this coarsely defined industry? And essentially what we find is that there is not much evidence that this is also benefiting the emission reduction of those kind of industries. If anything, again, we find that there is a significant worsening of scope 1 and scope 2 emissions as a function of this particular patenting activity.
Marcin, there's 2 more minutes.
Perfect. So kind of to link back to the replacement effect of arrow, you may ask yourself a question: why is it that potentially companies may not want to switch their type and actually try to innovate? So here is the table where we are trying to relate innovation to market share. And what you find is something quite interesting, which is innovation in the green space actually predicts the reduction in your market share in terms of the sales or assets of a company. So that kind of gives you a direct view that maybe companies don't have strong incentives to actually change their type, because that could actually be related to their losing some kind of big chunk of their market. We also look at this question of importance of innovation from the perspective of size of these effects. So what you are looking at here is the table which is trying to kind of decompose the marginal effects of the innovation in the way we predict decarbonization. And the evidence from this table tells you that the partial R-squares, where you try to measure the incremental value of innovation to explain the future emissions, is extremely tiny. We are talking about less than 0.5% of the variability in emissions that is due to innovation. So the bottom line of this is that we don't find really the overwhelming kind of evidence that innovation benefits in a big way decarbonization. So what does it bring us back to? Well, what it brings us back to is essentially the view that if we want to solve this problem, it is not just simply an idea that we need to send money to the companies that call themselves innovator. The policies that we need to think about in terms of informing this question in a meaningful way have to be a little bit more nuanced. So we need more kind of coordination of efforts across both companies and the public sector in the way how we are going to think about supporting this kind of innovation. Just thinking of a blanket policies that are just going to be channeling resources to what we call the green innovators doesn't seem to solve this problem, at least not obvious way, as we have identified in this paper. Thank you so much.
Thank you very much. If people have questions, just unmute and ask away.
I would like to ask a question.
Please go ahead.
Yeah, you obviously have impressive and rather gloomy results. I was wondering whether this might be related to a suggestion by Aguillon and his co-authors in their, I think it was 2012 paper on growth and subsidies. Because there his view was that large companies will file for patents not to actually use them, but to lock them up and keep the technology away from others so that they can sort of continue their brown activities. So.
No, I think that's a very good question. In some sense, the question is, why do companies even get involved in patents? One way is to actually scare away your competitors. Some companies may not even want to actually license their patenting activity because they want to keep it private to themselves. And we are very sympathetic to that comment. You are absolutely right. So the point of the paper is not so much to argue in a kind of very negative way that there is no way to solve this problem. Instead, what we are trying to say that if you think that there is an obvious way to solve this problem, which means let's support the patenting companies, there doesn't seem to be an overwhelming evidence that this is actually what's happening. So I don't want you to get a misleading kind of view of this paper. This paper is not to argue that there is no technology that could help us solve the decarbonization problem. What we are saying is that the results or the evidence on aggregate doesn't just stare at you and say, support anything that is called a green innovation. That could be maybe a misuse of resources. So in some sense, linking back to Aguillon, their view was like almost sidestepping this first step and assuming, let's assume that actually these companies are good innovators. What do we need to do to mobilize resources to actually support them? We are kind of taking one step back and saying, is this even validated? Do we actually observe that this patenting activity benefits what we are trying to achieve as an objective?
Other questions? So I have a question. So it's as also Sveta was saying, it's quite a dark conclusion. No, you don't want me to fully take that from that, but if you let's say if innovations are not the best policy to reduce emissions, what other policies, like is going sort of beyond this work, but what other policies do you think could help reduce emissions?
Yeah, no, this is a great question, which is of course the question that we all would like to answer. And I want to be a little bit modest in the sense that I wish I knew what is that perfect answer. I have kind of two perspectives on that. Like I've been doing this work for now a few years, so I have thought about it. I think what is the mistaken way to solve this problem is the way in which some economists have thought about carbon tax, where they thought that this is the only way to solve this problem. I grew to conclude that I think this is a wrong path to follow, that instead a more promising solution is a kind of patchwork solution, in a sense that we should try many things at the same time and just hope for the best, even if it leads to some kind of efficiency loss. I think we as economists, we have this tendency of thinking about first best and all sorts of efficiency kind of outcomes. And I think it's important. But I think this problem is a little bit like a lexicographic preference. In a sense, we can start thinking about efficiency once we address this problem to some extent. And I think that's important to recognize. In terms of more specific kind of solutions, Kim, that you are talking about, I think clearly one that I think maybe is something to support is to focus on existing technologies. So notice that here we are not saying that existing technologies are not working. We are talking about the technologies of the future. So rather than trying to think that maybe we are going to come up with some magic fairy in the future, maybe we should put resources to scale up actually what we already have. So of course, there is some evidence that we already have from different kind of technological areas, which suggests that maybe there is a way to at least reduce some of the carbon footprint. Sometimes the problem is, of course, how do you mobilize resources? How do you deploy these technologies spatially, etc.? And I think rather than spending billions of dollars, as some of these policies suggest to say, support these innovators, maybe some of this money should be targeted towards something that we already know to some extent is working. So that's kind of another perspective that I may offer on this particular question.
That makes sense indeed. You're just thinking, also given that we don't know what's going to be a success, right? But we basically hedge a bit by looking at many different types of policies.
Absolutely. I think this kind of public-private mix that I think nowadays people talk about is really the right way to think about it. I think the idea that we are going to leave this problem to governments to solve, as much as it sounds very attractive, I think practically speaking has not worked out. And you could argue that it has delayed some of the efforts to some extent because it led to inaction. There was not enough other activity basically to spare this particular solution.
And
yeah, Bernard.
Also...
Yeah.
Go ahead. Go ahead, Bernard.
Oh, you are muted, Bernard.
Bernard, you're muted.
You're too modest.
Okay, thank you. This button never works very well. So, Marcin, knowing you, I would have expected you to use some stock market data. And indeed, you have treated all innovations the same way, with the same weight. But some innovations are more important than others. And if you had given more weight to some important innovations, you might have found a slightly different conclusion. And so one way to give more weight to some innovation is to look at the stock market reaction to that innovation.
Mm-hmm. No, that's a great point. And in fact, Bernard, I'm sure that to some extent your question could be informed by the work by Leonid Kogan, Amit Seru, and Dimitris Papanikolaou. So essentially, they try to, or maybe not, it's possible that you came up with it on your own, but essentially, they have a way to classify the patents in this specific way, where they try to see which ones predict the stock market returns and use those as a kind of signal to classify as important. So first thing to say is that in our context, that would be difficult because many of these companies are kind of outside of the nexus where we can observe these reactions. But instead, Bernard, we have also looked at other metrics. We look at citations. We look at what we call blockbuster patents, where you focus on the tail of the distribution in terms of the citation. And we don't find that even by itself is making the results very strongly in favor of the innovation. So even in this subset of innovation that we look at, it's not that this is an overwhelming evidence that suggests that this innovation is actually beneficial. But again, I fully share your view that there could be patents that are actually good. We are just not able to identify them in a clear way. So that's a fair point to make.
Other questions?
Marcin, if I may. Sorry for coming in late. Maybe you already mentioned. What about carbon capture? Would it be? Would your analysis hint at that as well?
No, that's a great point, Giovanna. So partly it could be, like, in fairness, I will tell you, given the scope of the data, it's very hard for us to kind of go to the case study type of evidence. We could be going there if we knew what we are looking for. But one thing to keep in mind is exactly what I said in my answer to Kim, that something like carbon capture is a technology that to some extent already exists. So our paper is not about that. Our paper is about something that potentially can be used in the future. We are just talking about the first stage kind of creating a new technology. So that's exactly in spirit of what I was saying. Maybe we should use more resources to make it a larger scale kind of technology. Like carbon capture is clearly one of these potentially promising technologies that people have talked about. So absolutely agreed with you that this is one way maybe to think about the solution.
Other questions? Okay, then that is it for today. I first want to, of course, thank the presenters. So Xander and Marcin for great presentations, very interesting papers, and also all the participants, and especially for the interesting discussions after the presentations. I'd like to mention that next month on December 12th, we have another CAFFE seminar series. The topic then will be asset markets, and Elise Gourier and Gianpaolo Parise will be presenting their work. So I hope to see everyone again then, and thank you so much, and have a fantastic afternoon. Bye, everyone.
Thank you. Bye, everyone.
Okay.